In this lesson, we'll focus on domain name system attacks. The domain name system, also known simply as DNS, is a fundamental component of the internet that is responsible for translating human-friendly domain names into IP addresses that computers can understand. However, its critical role also makes it a prime target for cyber attacks. So let's explore some of the various types of DNS attacks, including DNS cache poisoning, DNS amplification attacks, DNS tunneling, domain hijacking, and DNS zone transfer attacks, and some of the mitigation strategies for each of these types of attacks. First, we have DNS cache poisoning. DNS cache poisoning, also known as DNS spoofing, involves corrupting the DNS cache data of a DNS resolver with false information. This leads the resolver to direct traffic to an incorrect IP address set up by the attacker, often to a malicious website. For example, an attacker could poison the DNS cache of a popular online banking website and then cause the bank's users to be redirected to a fake website where their login credentials could be stolen by the attackers. To prevent DNS cache poisoning, you should utilize DNSSEC or the Domain Name System Security extensions to add digital signatures to your organization's DNS data to ensure that its authenticity and integrity are confirmed during any DNS lookup. Also, you should implement secure network configurations and firewalls to protect your DNS servers from unauthorized access to prevent DNS cache poisoning from occurring on your systems. Second, we have DNS amplification attack. In a DNS amplification attack, the attacker exploits the DNS resolution process to overwhelm a target system with DNS response traffic. The attacker sends a DNS query with a spoofed IP address of their victim to an open DNS server, which will then send back a large response to the victim's IP address. For example, if an attacker could send a small query to an open DNS server to request a large amount of data like the entire list of hosts in a domain, this will be sent to the victim's IP address, which in turn causes a flood of unwanted traffic, which can appear to look like a DOS attack against the victim's system. One way to mitigate DNS amplification attacks is to limit the size of DNS responses or rate limit any DNS response traffic to mitigate the impact of this type of attack. Third, we have DNS tunneling. DNS tunneling involves using the DNS protocol to encapsulate non-DNS traffic such as HTTP or SSH over port 53 to attempt to bypass the organization's firewall rules in order to conduct command and control or data exfiltration. DNS tunneling is actually a legitimate technique, but is often exploited by attackers for their own malicious purposes. For example, an attacker could use DNS tunneling to bypass a company's firewall and to exfiltrate sensitive organizational data. Since DNS requests are usually allowed to pass through a firewall without inspection, DNS tunneling is quite effective for sneaking data out of a given network. For this reason, it is important that you regularly monitor and analyze your DNS logs for any signs of unusual patterns or behaviors that could indicate DNS tunneling is occurring. Fourth, we have domain hijacking. Domain hijacking, also known as domain theft, involves the changing of the registration of a domain name without the permission of the original domain's registrant. Domain hijacking can lead to loss of control over a website and potential redirection to a malicious website in place of the organization's real website. For example, if an attacker could hijack a popular e-commerce website domain like Amazon.com, they can redirect all of Amazon's traffic to a fake website where a customer's payment information could be stolen. Again, conducting regular updates and ensuring your registration account information is secure is the best defense against domain hijacking. Additionally, you should use domain registry lock services to prevent any unauthorized changes to your domain registrations to prevent domain hijacking from occurring in the first place. Fifth, and finally, we have DNS zone transfer attacks. In a DNS zone transfer attack, the attacker tries to get a copy of the entire DNS zone data, which includes all of the DNS records for a domain, by pretending to be an authorized system making that request. This type of an attack can expose sensitive information about the network's infrastructure of the domain and can be used as reconnaissance for planning future attacks against a given organization. So remember, DNS attacks exploit the domain name system's vulnerabilities to disrupt service, steal information, or redirect a website's traffic. DNS cache poisoning involves corrupting a DNS resolver's cache. DNS amplification attacks uses the DNS resolution process to flood a target with traffic to create a denial of service type of condition. DNS tunneling can be used to bypass firewall rules, and to conduct data exfiltration. Domain hijacking involves unauthorized changes to a domain's registration, and the DNS zone transfer attack aims to get a copy of a domain's DNS zone data. By understanding how these attacks are performed, you can easily put mechanisms in place to prevent them from happening.